Hello, friend, and welcome to the Sleepy Meteorologist. Tonight, we're gently drifting into the quiet world of snowfall, a soft, white hush that covers the world in stillness, one delicate flake at a time. We'll wander through the dreamy layers of wintry skies, from the moment a snowflake begins to form, to the peaceful silence that lingers after the storm has passed. There's something timeless about snow, a kind of calm that touches rooftops, branches, and quiet roads, turning even the busiest places into gentle, slow-moving worlds. Maybe your day has been full, or maybe you've simply been waiting for a moment of peace. Either way, this space is for you. What's the weather like where you are right now? Can you feel the chill just by remembering? That soft sting in the air, the quiet crunch underfoot, or the way everything seems to pause beneath falling snow. If you find comfort in these peaceful weather journeys, you're always welcome to subscribe. Only if it feels restful to do so. There's no pressure here, just presence. Now, let's nestle in. Let your breath slow. Let the snow fall softly in your thoughts. Let's begin. Snow doesn't begin on the ground. It begins far above us, in the quiet, cold layers of the atmosphere, where the world slows down and softens. Up here, among the clouds, the temperature is often well below freezing. The air is thin, hushed, and full of invisible promise. Moisture lingers here, floating gently in the form of vapor, suspended like breath, held in a moment of stillness. This vapor is waiting, watching, you might imagine, for just the right conditions. And when the air is cold enough and the tiniest of particles pass through, dust, pollen, even tiny fragments of sea salt or volcanic ash, a transformation begins. A single droplet of water clings to this nucleus and freezes, and that is the beginning of a snowflake. But it's not a sudden process. The flake doesn't burst into being, it grows, slowly, quietly, breath by breath of cloud vapor. Molecule by molecule, water vapor settles onto its surface, freezing instantly, adding to the crystal's delicate arms. As we float through these hidden chambers of sky, it's as if we can watch the flake building itself, a tiny architect, crafting symmetrical arms with icy precision. Every branch of the snowflake mirrors the others, not by magic, but by the simple constancy of temperature and time. The environment around the flake, the cold, the moisture, the currents of air, sculpts its pattern. Yet no two are exactly alike. Even the smallest shifts in humidity or warmth change the outcome, creating endless variety in a world of quiet repetition. We often think of snow as something that simply falls, but before it does, it lives here, in the silence. A flake may linger in the cloud for minutes, even hours, growing, waiting, spinning slowly in updrafts, cushioned by wind. It isn't falling yet, it's forming, and up here, forming is a process of patience. It begins with a seed of ice and becomes something far more intricate, shaped by invisible hands. In a single cloud, countless flakes are born in this way, each with its own silent journey ahead. But right now, in this quiet corner of the sky, we watch only one. It expands slowly, its 6 arms branching with fragile elegance. It is so small, so impossibly light, yet full of detail, too fine for the eye to see unaided. Its existence is brief, but beautiful, a single moment of frozen balance. And when it is ready, not rushed, not hurried, the flake begins to descend. Gravity reaches for it gently. The air, ever protective, resists just enough to slow its fall. The flake begins to drift downward, leaving the cloud, entering the open sky between cloud base and earth. But here, in this chapter, we pause before that journey. We remain in the birthplace of snow, this invisible nursery above the world, where quiet cold and patient time give rise to something soft, crystalline, and endlessly unique. Snow doesn't shout when it forms. It doesn't rush. It simply begins, silently, gently, invisibly. Every snowflake holds a secret, one that begins with the number 6. 6 arms, 6 points, 6 branches, all radiating from a center with perfect balance. This symmetry is not a coincidence. It is the quiet result of physics, temperature, and time. When a snowflake forms in the upper atmosphere, it begins around a tiny frozen droplet. As water vapor lands and freezes onto this seed, it expands outward, always in 6 directions. Why 6? Because of how water molecules bond together in cold conditions, forming hexagonal patterns by nature's own quiet rules. In this chapter, we follow one flake's story from its first breath of ice. At first, it is simple, a frozen disk, but as it drifts through the sky, each arm begins to grow. The temperature around it, the moisture in the cloud, even the faintest movement of air influence its shape. Some flakes remain plain and tidy, solid plates or slender needles. Others blossom into complex stars with feathery branches, like frozen ferns or lace made of light. The beauty lies not just in their design, but in their journey. Each snowflake is a traveler, carrying the memory of the sky it passed through. No two are exactly alike, because no two paths are. Even flakes that begin side by side will wander through different swirls of humidity, different shifts of wind. A moment of warmth might round an edge. A cooler pocket might sharpen it again. One side might grow faster than the other, but somehow the flake balances itself, always returning to 6. Scientists have spent decades studying snowflakes, cataloguing their shapes, photographing their symmetry. But even with all we know, each flake still feels like a little wonder, a moment of fleeting perfection, visible for only a breath of time before it melts away. As we float with our snowflake, we begin to see what it sees. The slow rotation as it drifts downward, the light filtering through its crystalline arms, the quiet artistry of the atmosphere, crafting beauty from breath and cold. Each branch grows independently, but under the same conditions, and so symmetry forms without intention. It's a natural consequence of balance in a gently chaotic world. Some scientists say that snowflakes are like frozen records of the sky. They hold within them tiny clues about the air, the humidity, even the altitude at which they were born. In this way, each flake is not just beautiful, but informative, a silent messenger from above. Even as the flake nears the ground, it keeps its 6-sided form. It lands on a sleeve, a window pane, a field of white, and for a brief moment, its perfect symmetry can be seen by the naked eye. Then, softly, it melts. The flake disappears, but the pattern remains in our memory. This is nature's quiet mathematics, a geometry of stillness shaped by the air. Snow begins in silence, and it arrives the same way. When a snowflake finally begins its descent from the cloud, it doesn't plummet like rain. It drifts, floats, wanders. Its journey is slow, and so very soft. Unlike raindrops, which fall quickly and strike the ground with rhythm and sound, snowflakes take their time. They fall at just a few feet per second, some drifting even slower than that. Their shape gives them lift, like tiny parachutes, and the sky itself seems to cradle them. But the path from cloud to earth isn't simple. Along the way, the flake may pass through layers of dry air, where it begins to sublimate. evaporating before it even touches the ground. Or it might tumble into a warmer current and begin to melt, turning into sleet or soft rain. Only the most fortunate flakes, those cushioned by cool, moist air all the way down, complete their journey intact. These are the ones that fall gently past windows, land on quiet rooftops, and melt slowly on mittened hands. As it falls, the flake is still changing. Wind may twirl it, air pressure may stretch it. It's a journey of grace, a soft descent shaped by the sky itself. Snowflakes can collide in midair. Some stick together, forming clusters. Others break apart. The atmosphere is alive with motion, and every inch of its journey adds a brushstroke to the snowflake's final form. Sometimes the air is filled with so many flakes, all drifting together, that the world below begins to quiet. Sounds become muffled, edges soften, light scatters through the falling crystals, making everything seem just a little more magical. And when the snow finally lands, it does so without a sound. No splash, no crack, just contact and stillness. On a cold enough night, you can watch flakes pile one by one, layering gently, covering the ground in softness. Each flake is part of something larger now, a gentle accumulation that blankets the world in white. From above, it looks like a whisper made solid. From below, it feels like the sky has come to rest. This fall is not just gravity, it's choreography, an atmospheric ballet of lightness and time. And finally, with no sound at all, it lands, a kiss upon the earth, a hush upon the world. Not all snow is alike. Some falls like a whisper, dry and feathery. Others arrive heavy and full, clinging to branches and gloves with a sleepy weight. Each type of snow tells a story, not just about the clouds it came from, but about the air it passed through and the moment it met the world. Tonight, we'll become gentle snow collectors, tracing the differences one flake at a time. Powdery snow is the kind that skiers dream of. Light, airy and dry, it tumbles over itself like sifted flour, rising in soft puffs with every step. This snow forms in very cold temperatures, where ice crystals remain separate, never melting or clumping together. It glides through the sky and rests in quiet, fluffy piles, a dusting of winter's breath. Wet snow, by contrast, has a sleepy heaviness. It falls when temperatures hover near freezing, and each flake carries extra moisture. When it lands, it sticks. It clings to tree limbs, mailboxes, and coats. It makes perfect snowballs and sturdy snowmen. Walking through wet snow feels like stepping through a soft sponge, each step cushioned but sure. Then there's crusty snow. This one has a memory. It begins soft, then meets sunlight. The surface melts slightly, then freezes again overnight. A delicate shell forms on top, crackling underfoot. Sometimes you stay on top of it. Other times, your boot crunches through. It makes a sound the rest of the world doesn't, like ice whispering secrets to the earth. Graupel is a curious kind of snow. Tiny pellets, soft but round, like miniature snowballs falling from above. They bounce, they scatter, and they feel almost like soft hail. But they're not hard. They're formed when supercooled water droplets freeze onto falling snowflakes, creating tiny coats around each crystal. The result is a gentle shower of snowy beads. There are also needle-shaped snow crystals, thin, icy slivers that form in slightly warmer layers of the atmosphere. And sometimes we see dendrites, the snowflakes with classic six-armed symmetry. Broad, detailed, and beautiful. These are the ones you might catch on your mitten and admire before they melt. Each of these forms reflects something about the sky above, the temperature, the moisture, the wind. Meteorologists learn to read snow the way one might read tree rings or ocean waves. And you can too. Next time snow falls, step outside. Catch a few flakes on a dark sleeve. Notice their shapes, their textures, their weight. Snow isn't just white. It's layered with meaning, and each flake, whether powder, pellet, or plate, is part of the story the clouds are telling that day. Let's listen closely, one dreamy snow type at a time. There's a hush that follows snow, a quieting of the world that feels both strange and sacred. After a heavy snowfall, something changes in the air. Streets soften, footsteps vanish. The landscape feels wrapped in stillness, like a dream you haven't woken from. Why does snow make everything quieter? The answer lies not in the snowfall itself, but in what it leaves behind. A fresh layer of snow is made up of millions, billions of tiny ice crystals. Each one is full of gaps and spaces, and when snow blankets the ground, those gaps form a porous surface, one that catches sound, like a cushion, like insulation, like a blanket, not just for the earth, but for the noise. Sound waves, instead of bouncing off hard surfaces, sink into this soft snow layer. Their echoes are absorbed, their edges are dulled. Even the loudest sounds, traffic, footsteps, voices, become softened and blurred. Snow doesn't just cover the world, it muffles it. In cities, snowfall can turn a bustling street into a quiet corridor. In forests, it deepens the sense of stillness. Every crackling branch or rustling animal becomes amplified, not by volume, but by contrast. Silence isn't the absence of sound, it's the presence of peace. This softening effect doesn't last forever. Over time, the snow compacts, the air pockets collapse, the hush fades. But in those early hours after a snowfall, when the snow is still fluffy and fresh, the quiet is palpable. There's also something psychological at play. Snow changes what we see, as well as what we hear. Familiar places look unfamiliar under a layer of white. The edges blur, the colours fade, and with visual noise reduced, our brains respond by relaxing. It's as if the world, for a moment, is asking us to lower our voices, to breathe slower, to listen not to what's being said, but to what is no longer being said. Imagine yourself stepping outside at night after a snowfall. The world is silver and still. Your boots press softly into the powder. The only sound is the gentle crunch beneath your feet. Even that sound feels quieter than usual, as if the snow itself is listening. Children notice it first, the way voices carry less, the way even laughter becomes muffled. Animals respond too. Birds go quiet, squirrels pause. The natural world waits, wrapped in the same stillness. Scientists measure this acoustic dampening. A few inches of fresh snow can absorb high-frequency sounds remarkably well, reducing ambient noise by several decibels. It's a natural form of soundproofing, a soft, white hush engineered by the atmosphere. But for most of us, it isn't about science. It's about the feeling. The quiet after snow isn't just physical, it's emotional. It touches something in us that longs for rest, for peace, for a world that, just for a little while, isn't asking anything from us. Tonight, we step into that silence, not to analyze it, but to feel it, to breathe with it, to let it settle gently around us, like the snow itself. A hush upon the ground, a quiet in the air, and inside us, something softens too. There are few sights in nature more calming than snow touched by moonlight. When the snow is fresh and the sky is clear, something magical happens. The moon, silent and distant, casts its glow across the land, and the snow, cool, quiet and reflective, returns that light in every direction. It doesn't shine like metal. It doesn't sparkle like glass. It glows, softly, subtly, as though the ground itself has become a source of gentle radiance. In this chapter, we take a nighttime walk. The snow is deep. The air is still. Above us, stars twinkle faintly through the branches. Below, the snow reflects the sky. Each step we take is muted. The crunch beneath our boots is quiet, respectful. Shadows stretch long and soft. Trees cast silver outlines across open fields. Fence posts glow faintly, and rooftops seem dusted with moonlight itself. Snow reflects nearly all the light it receives. But unlike other reflective surfaces, it scatters that light. Each tiny flake becomes a miniature mirror. Together, they create a diffuse, dreamy illumination that softens the world. In moonlit snow, the world becomes gentler. The sharp lines of daylight fade. The colors melt into silver and pale blue. Everything feels slower, quieter, suspended. Sometimes, if the snow is still falling, the light catches each flake in motion. You can see them drifting downward, glowing briefly, then vanishing into the folds of snow below. It's like watching stars fall from the sky, one after another. No artificial light is needed. In fact, it would only intrude. Moonlight and snow need no help to create beauty. They've been doing it for eons, before cities, before roads, before time had a name. Some animals move in this light. A fox stepping lightly across a field, an owl gliding silently overhead. Their tracks are etched gently into the silver surface, like temporary constellations on the earth. Even the air feels different, crisper, more still. You might stop walking just to listen, to hear what the moonlit snow is not saying. And in that stillness, you realize the world isn't asleep. It's simply at peace. Photographers and poets have tried to capture this moment, but its magic is best felt, not described. It's a kind of nighttime that doesn't feel dark, a landscape lit from below, a world painted with light, but not disturbed by it. To walk in snow under moonlight is to enter a dream while still awake, a dream made of light, silence, and softness. It calms the heart, it slows the mind. Tonight, we walk slowly. No destination, just the rhythm of breath, the softness of the snow, and the glow of the moon lighting our path. The world, touched by moonlight, has never felt so quiet. Snow does not always fall and settle evenly. When the wind begins to move through a snowy landscape, it sculpts the surface into soft, shifting shapes. These are the snow pillows and drifts, silent expressions of motion captured in white. Tonight, we follow the wind, not as something fierce or cold, but as a quiet artist, reshaping the world with breath and time. After snowfall, even the slightest breeze can lift loose powder from the surface. Tiny crystals are picked up and carried through the air, twirling like dancers. And as the wind begins to slow, those flakes fall again, not in the same place, but wherever the air allows them to rest. Over hours, sometimes days, this process repeats. What begins as a flat field becomes something else entirely. Waves of snow rise and curl, as though the landscape were once liquid and suddenly stilled. These snowdrifts form along fences, walls, and the leeward side of trees. They stretch like frozen dunes across open spaces. Some are sharp-edged, others are smooth as silk. Snow pillows, on the other hand, are gentler, soft mounds that gather over rocks, bushes, and tree stumps. They form where the snow settles deeply and undisturbed, wrapping itself around the object below like a downy quilt. Their curves are round and quiet. Their presence feels comforting, like cushions placed by nature's hand. As you walk among them, notice the variety. No two drifts are exactly alike. Some rise waist high, others whisper along the ground. Some have ripples, carved by steady breezes. Others are wind-smoothed and seamless. In forests, drifts may curl around the bases of trees, forming gentle collars of snow. In open plains, they stretch into vast rolling patterns, white waves frozen mid-motion. If you listen closely, the wind that shaped them still lingers, barely brushing your cheeks, always rearranging, always designing. This movement isn't chaotic, it's patient, gradual. The wind does not rush. It works over time, coaxing snow into sculpture, a kind of collaboration between air and ice. And when the moonlight hits these forms, they cast long, soft-edged shadows. The texture of the snow becomes visible in new ways. Dunes appear like frozen ocean swells. Snow pillows glow faintly beneath branches. Even the tiniest drift sparkles with complexity. Some drifts are so smooth you hesitate to step on them. Others look like the folds of a soft blanket tucked across the land. All of them hold stories of how the air has moved, where it paused, where it circled back, where it decided to lay the snow down gently. And then there are cornices, overhanging ridges of snow formed where wind blows snow over edges, often seen on rooftops or mountain cliffs. They appear delicate, like wind-blown fabric turned to crystal. They remind us that snow, though soft, can be shaped into sharp elegance. As we walk through this drifted world, we learn to see the wind's invisible signature, not as a line, but as a contour, not as noise, but as form. We're witnessing sculpture in progress, the quiet art of reshaping without sound. So, let us pause here, amid these soft waves of white. Let the wind guide our eyes. Let the drifts tell us where it once moved, and let the stillness now remind us of how gentle change can be. Sometimes the world wakes up wearing lace. It's early, the sky is pale, the air holds its breath, and everything, every branch, every fence, every forgotten post is coated in white detail. This is not snow. This is frost and ice, formed not from above, but from the very air around us. Hoarfrost appears when water vapor in the air touches a surface that is colder than freezing. The moisture turns directly into ice, skipping the liquid stage entirely. And when it does, it builds delicate patterns, spikes, feathers, ferns. It grows outward in silence, layer by layer. We walk slowly this morning. Each twig holds a fragile coating. Leaves are edged in white. Even the spiderwebs are frozen, each thread now a glistening filament of ice. The world feels paused, but alive. Hoarfrost is light and feathery, often mistaken for snow. But it forms differently. No clouds are needed. Just clear skies, calm wind, and moisture in the air. It often appears after a cold, still night and vanishes soon after the sun rises. It is one of nature's most temporary wonders. Then there is rime ice, similar in appearance, but heavier, more solid. It forms when freezing fog moves through the air. Tiny droplets of supercooled water collide with surfaces and freeze on contact. Unlike hoarfrost, which grows slowly in place, rime builds with motion. You might see rime on windward branches, building outward like spines. It has direction, a shape that tells you which way the fog was moving. It's often found near mountain peaks, radio towers, or coastlines, where fog is frequent and temperatures dip low. Both hoarfrost and rime ice are artists. Their tools are time, moisture, and cold. Their canvas is the world. Imagine walking through a forest after a night of hoarfrost. The trees are white, not from snow, but from a layer of lace. Every needle of every pine is outlined. Every twig has become a crystal wand. The ground may be bare, yet the trees look as though they've stepped out of a winter fairy tale. Or picture a fence line, rhymed in ice. The wind has shaped each wire, each post, with a veil of frozen mist. It's not chaotic, it's quiet, it's balanced, and it's brief. These ice formations catch the morning light like prisms. Even a small breeze can send a flurry of delicate flakes into the air. The sound is nearly imperceptible, a soft whisper, a faint rustle. And then, it's gone. To witness hoarfrost or rime ice is to witness transience. They are here, then not. They do not demand attention. But if you're still enough, they reward your gaze. Meteorologists study them to understand humidity, dew points, and freezing conditions. But here, in this moment, we don't need numbers, just wonder. So breathe in the stillness. Let your eyes soften. Let the details emerge from the quiet. This is the morning lace of winter, formed in silence, gone by midday. But for now, it is all around us. To the naked eye, a snowflake is a brief glint, a soft shape in descent, a whisper of ice landing on your glove. But magnified, truly magnified, it becomes something else entirely. A world of symmetry, of pattern, of delicate, frozen art. Tonight, we shrink our gaze and step inside this miniature universe. A place where no two shapes are quite the same, yet all follow the same quiet laws of nature. When snowflakes are placed beneath a microscope, their details emerge like secrets. What looked like a speck becomes a six-armed star. Some have pointed tips. Others wear ornate patterns like frosted lace. A few are simple, neat hexagons with clean edges. Others are elaborate, feathered, and endlessly intricate. Each flake begins with a single ice crystal, and as it falls through the atmosphere, it grows, its arms branching outward in perfect symmetry. But the air is never still. Humidity shifts, temperature changes, and so each arm, though influenced by the same center, begins to respond in its own way. Scientists use microscopes to photograph these tiny wonders. Some flakes measure less than a millimeter wide. Yet, within that small space, a complete geometric story unfolds. Every branch a response to moisture, every notch shaped by time. Some snowflakes form as simple plates, smooth and flat. Others grow into dendrites, branching structures that resemble ferns or coral. There are stellar plates, needles, columns, capped columns, and radiating scrolls. Each form corresponds to a temperature and humidity range in the cloud it passed through. The crystal isn't random, it's responsive. To look at a snowflake up close is to glimpse the balance between order and chaos. The basic pattern, six-sided symmetry, remains consistent, but the details shift, twist, and flare into endless possibilities. It's like a frozen fingerprint made of water and air. In older times, people believed snowflakes were symbols, messages from the heavens, tiny stars fallen to earth. Even today, their shapes inspire awe. Crafts, holiday decorations, and art often mimic these crystalline forms, though none can match the intricacy of nature's quiet hand. And here's something curious. Though we say no two snowflakes are alike, that's not just poetic, it's statistically true. The number of possible branching combinations, given all the atmospheric variables, is astronomically large. You could wait 1,000 lifetimes and never see the same pattern twice. In research labs, snowflakes are grown under controlled conditions to study their behavior, but even then, variations occur. Nature resists repetition. It prefers variation, surprise, subtle difference. Tonight, as we gaze through this imaginary lens, we let our eyes soften. We drift along each branch of ice, tracing its ridges, its turns, its silvery edges. It feels like wandering through a tiny, frozen forest. Each flake is a world, brief, weightless, entire. And as we zoom out, again, pulling away from the magnified detail to see the whole, we understand something gentle, that even in the smallest things, beauty thrives. That even a single snowflake, seen clearly, holds enough wonder to quiet the mind. The next time snow falls, you might catch one on your coat sleeve. Before it melts, look closely. You won't see every ridge, but you'll know they're there. A moment of hidden symmetry, a dream caught in glass. Snow doesn't just fall and melt. Sometimes it lingers. Layer by layer, flake by flake, it builds upon itself until it becomes something more, a snowpack. Not just a collection of snow, but a slow-forming blanket that reshapes the world beneath it. In this chapter, we explore what happens below the surface of a snowy field, a hidden world where cold is constant and change happens quietly. A snowpack begins with the first snow of the season. That initial layer settles onto the ground, cooling the soil below. Each snowfall after adds another layer, sometimes dry and airy, sometimes dense and wet. Over time, the weight of the snow compresses the lower layers. Air pockets shift. Ice crystals change shape. A process called sintering begins, where snowflakes fuse together, creating a more cohesive mass. Inside the snowpack, temperature plays a quiet role. The uppermost layer is often the coldest, exposed to frigid air. Beneath, the snow acts as insulation, keeping the ground warmer than the air above. This counterintuitive effect helps protect roots, burrowing animals, and dormant seeds from the harshest freezes. Tiny tunnels form within the snowpack, pathways carved by wind, warmth, or animals. Voles and mice create entire networks beneath the snow, safe from predators and weather. Their breath warms the air around them, just enough to keep their shelters from icing over. Even foxes and owls know to listen for the sounds beneath the snow. Life goes on, quietly, out of sight. Some snowpacks last for months. In mountain regions, they store winter's water supply, slowly releasing it in spring as runoff. Scientists study these layers to predict floods, measure climate shifts, and understand seasonal change. The snowpack can also tell us stories. Layers of ice crusts may indicate melting events followed by freezing. Dust layers might mark a windstorm from distant deserts. Even volcanic ash, on rare occasions, becomes preserved between snowy sheets. And then there's the pressure. As the snowpack deepens, it becomes denser. The grains of ice inside metamorphose, changing from fluffy crystals into firmer forms. Over long periods in glaciers, this transformation continues until snow becomes solid ice. But even in seasonal snowpacks, the process is always underway. Walking on a snowpack feels different than walking on fresh snow. Your feet don't sink as deeply. The surface may crunch, or hold steady, or suddenly collapse. Each sound underfoot tells you something about the structure below. And when you sit on a snowpack, perhaps on a frozen hillside, wrapped in a thick coat, you can feel its chill rising through the layers. It's not a harsh cold. It's a steady, present kind of cold. A reminder of how snow changes not just the surface, but the entire landscape. Beneath the snowpack, the earth breathes more slowly, the soil rests, the insects pause, the rhythm of life itself quiets down. In this stillness, the snow is not passive. It is protective, active in its own way, preserving, cooling, softly pressing its presence into the world below. So tonight, let us lay quietly on the snowpack, just for a moment. Let us feel the weight of winter, not as a burden, but as a blanket. Deep, ancient, still, the earth wrapped in white, the world held in pause. The first snowfall of the season doesn't always arrive with fanfare. It often comes softly, like a breath released slowly from the sky. One moment, the world is still autumnal. The air is crisp, but bare. The next, a flake appears, then another, and then the sky is filled with them, floating downward in slow spirals. Tonight, we welcome this quiet arrival, the beginning of winter's gentle transformation. The first snow feels different than the others. It's new, anticipated. There's something almost ceremonial about it. Children press their faces to windows. Grown-ups pause mid-step to glance upward. The light catches the flakes just right, and for a moment, it feels like time itself slows down. Meteorologically, the first snowfall occurs when the upper atmosphere cools enough for precipitation to fall as snow rather than rain. Often, the ground is still warm from autumn's touch, so the snow may melt upon contact. But when conditions are just right, when air temperatures hover around freezing both above and at the surface, snow can accumulate. Before that first snow, certain patterns emerge. Cold fronts sweep in, winds shift. High pressure settles in behind the front, drawing in drier, cooler air. Clouds begin to thicken, low and layered. The humidity builds quietly, and moisture lingers, waiting to condense. Then, often without warning, the snow begins. The flakes may be small and sparse at first. They dot the sidewalk like specks of ash. But gradually, they multiply. The trees begin to hold them on their bare branches. Grass fades beneath a fine dusting. Roofs take on a powdery outline. Everything is suddenly quieter. There is a palpable change in the atmosphere. The first snow cools the air, lowering temperatures gently. It muffles sound, creating the soft hush we've come to associate with winter. It resets the palette of the world, from browns and rusts to whites and silvers. And there's an emotional shift too. Whether welcomed or not, the first snow reminds us of change. It signals the turning of seasons, the approach of deeper cold, the quieting of the landscape. For meteorologists, this event is carefully tracked. The timing of the first measurable snowfall tells us much about the coming winter, whether it's arriving early, late, or right on time. But outside the data, it simply feels magical. It's the snow we remember best from childhood. The snow that draws us out for a walk, even when it's just a dusting. The snow that turns headlights into halos and transforms even the most familiar path into something new. We step gently into this changed world. Our breath is visible. The sky glows softly, reflecting light off the descending flakes. And beneath our feet, the crunch of snow begins to return. This first snowfall is a signal. It tells plants to rest. It reminds animals to prepare. It nudges us to pause, to notice, to breathe. And though it may melt quickly or vanish by morning, it leaves an impression, not just on the ground, but on the mind. The first snow doesn't have to last to be meaningful. It simply has to arrive. And when it does, we feel it. A change in the air, a softening of the world, a whisper from the sky. That winter is near. The first snowfall of the season doesn't always arrive with fanfare. It often comes softly, like a breath released slowly from the sky. One moment, the world is still autumnal. The air is crisp, but bare. The next, a flake appears. Then, another. And then, the sky is filled with them, floating downward in slow spirals. Tonight, we welcome this quiet arrival, the beginning of winter's gentle transformation. The first snow feels different than the others. It's new, anticipated. There's something almost ceremonial about it. Children press their faces to windows. Grown-ups pause mid-step to glance upward. The light catches the flakes just right, and for a moment, it feels like time itself slows down. Meteorologically, the first snowfall occurs when the upper atmosphere cools enough for precipitation to fall as snow rather than rain. Often, the ground is still warm from autumn's touch, so the snow may melt upon contact. But when conditions are just right, when air temperatures hover around freezing both above and at the surface, snow can accumulate. Before that first snow, certain patterns emerge. Cold fronts sweep in, winds shift, high pressure settles in behind the front, drawing in drier, cooler air. Clouds begin to thicken, low and layered. The humidity builds quietly, and moisture lingers, waiting to condense. Then, often without warning, the snow begins. The flakes may be small and sparse at first. They dot the sidewalk like specks of ash. But gradually, they multiply. The trees begin to hold them on their bare branches. Grass fades beneath a fine dusting. Roofs take on a powdery outline. Everything is suddenly quieter. There is a palpable change in the atmosphere. The first snow cools the air, lowering temperatures gently. It muffles sound, creating the soft hush we've come to associate with winter. It resets the palette of the world, from browns and rusts to whites and silvers. And there's an emotional shift too. Whether welcomed or not, the first snow reminds us of change. It signals the turning of seasons, the approach of deeper cold, the quieting of the landscape. For meteorologists, this event is carefully tracked. The timing of the first measurable snowfall tells us much about the coming winter, whether it's arriving early, late, or right on time. But outside the data, it simply feels magical. It's the snow we remember best from childhood, the snow that draws us out for a walk, even when it's just a dusting, the snow that turns headlights into halos and transforms even the most familiar path into something new. We step gently into this changed world. Our breath is visible. The sky glows softly, reflecting light off the descending flakes. And beneath our feet, the crunch of snow begins to return. This first snowfall is a signal. It tells plants to rest. It reminds animals to prepare. It nudges us to pause, to notice, to breathe. And though it may melt quickly or vanish by morning, it leaves an impression, not just on the ground, but on the mind. The first snow doesn't have to last to be meaningful. It simply has to arrive. And when it does, we feel it. A change in the air, a softening of the world, a whisper from the sky that winter is near. When we think of snowflakes, we often picture the classic six-pointed star, delicate, feathery, symmetrical. But snow comes in many forms. Some flakes are compact and grainy. Others are flat, plate-like, or slender like needles. These subtle differences tell a deeper story about the atmosphere. Tonight, we become quiet observers of these tiny frozen geometries. Snow grains are small, rounded pellets of snow, not to be confused with sleet or hail. They form when temperatures hover just below freezing and moisture in the cloud is limited. These grains fall gently and accumulate slowly. You might notice them as a soft layer that builds without much drama, quiet, unobtrusive, like the breath of winter. Unlike classic snowflakes, snow grains don't have arms or branches. They don't sparkle in the same way, but they're important. They mark a colder, more stable phase in the atmosphere, often a precursor to more significant snow. or a sign that the weather is holding steady. Then there are the crystals, the ice plates and columns that form when humidity is low, and the air is dry and chilled. These crystals grow slowly, layer by layer, flat and wide. Under magnification, they resemble miniature mirrors or geometric discs. They're often too small to see clearly with the naked eye, but together they form a shimmering surface on the snowpack. These plate-like forms are especially reflective. When they land on the ground in large numbers, they can create dazzling effects, sundogs, halos, and other optical phenomena when struck by sunlight or moonlight. Some crystals grow into needles, long, slender formations that form in warmer, moist conditions, often around -5 degrees Celsius. These needles fall quickly and pile lightly. They don't interlock the same way branched flakes do, so snow made of needle crystals feels soft and airy underfoot. If you've ever walked through a snowfall that seemed to tickle your cheeks with tiny pricks, you were likely surrounded by needle crystals. Each shape, grain, plate, needle, or column tells a story about the altitude, temperature, and moisture content of the clouds above. Meteorologists use these forms to read the sky like a book, interpreting the atmosphere's quiet messages. And sometimes, different types fall together. The upper atmosphere may hold cold, dry layers, producing plates, while a warmer layer below adds needles. The result is a mixed blanket of snow that crunches, shimmers, and flows with complex beauty. We don't always notice these differences, but when we do, when we pause to examine what's falling, we find that snow is not just snow. It is a collection of shapes, patterns, and textures, each one shaped by invisible hands. Tonight, let us peer closely at the flakes that gather on a scarf, a windowsill, a glove. Let us notice whether they are star-shaped, or rounded, or flat. Let us imagine the journey they took through layers of sky, each layer sculpting a different feature. Snow is the atmosphere's signature, written not in ink, but in frost. And when we learn to read it, even the smallest flake becomes a quiet message from above. Snow has many origins, but one of the most beautiful begins with the mountains. When wind carries moist air toward a mountain range, something quiet and powerful begins to happen. The terrain rises. The air has no choice but to follow. And as it rises, it begins to cool. This is orographic lift, a gentle, persistent process where the shape of the land guides the behavior of the sky. Tonight, we float with that air. We let it lift us slowly up the slope of a snow-covered mountain. As the air climbs, it expands. The pressure drops. The temperature falls. Moisture that once floated unseen begins to condense into tiny droplets. Clouds appear like breath against the cold. Higher still, the droplets freeze, and flurries begin to form. From the base of the mountain, we look up and see nothing unusual. But from within the clouds, we watch snowflakes take shape and begin their descent back down the windward side, the side that faces the approaching air. The snowfall here is not caused by a storm system or a cold front, but by geography. The land itself is drawing snow from the sky, one ridge at a time. This snow can be deep, even when skies are calm elsewhere. In fact, orographic snowfalls are often deceptively local. A single peak may be wrapped in white, while valleys below remain dry. Travelers crossing mountain passes experience this change firsthand, the sudden shift from clear roads to flurries, to drifts, to silence. Each mountain is different. Some ranges, like the Cascades or the Sierra Nevada, receive abundant orographic snow because they stand tall and intercept moist ocean air. Others collect smaller amounts, but still shape the weather around them, guiding clouds and carving snowbelts into the landscape. And it doesn't take dramatic peaks. Even small ridges and rolling uplands can lift air just enough to trigger snowfall. The snow that forms from orographic lift tends to be light and persistent. It drifts down gently, hour after hour, layering the slopes. It feeds alpine forests, nourishes glaciers, and provides water to rivers far below. Meteorologists study these patterns to understand snowpack levels, avalanche risks, and seasonal runoff. But from our quiet place among the clouds, we simply watch the sky meet the land. Rising air, cooling slowly, moisture turning to flake, a ridgeline disappearing beneath a veil of white. Even the sound changes in these places. The wind carries the soft whisper of falling snow. Trees are dusted in powder. Footsteps vanish quickly. The mountain exhales clouds from its peaks, and when the air descends on the other side, on the leeward slope, it warms again. The snow stops, the clouds dissolve, the land returns to stillness. This is the mountain's breath. Inhale, snow. Exhale, sun. A quiet partnership between land and sky. Mountains don't just hold snow, they make it. There are places where lakes seem to speak to the clouds, where water and wind combine to create something uniquely local, deeply dreamy, and wonderfully snowy. This is lake effect snow. It begins when cold air sweeps across the surface of a warmer lake. The lake, still holding autumn's memory, releases moisture into the air above it. That moisture rises, cools, and condenses. And under the right conditions, snow begins to fall, narrow bands of it, focused and persistent. Tonight, we drift with that air as it moves across a lake's surface, drawing warmth and breath from the water below. The snow that results from this exchange doesn't fall everywhere. It falls in streaks, ribbons of white that stretch inland, carried by wind. These snow bands can be surprisingly narrow. One town may be buried in snow, while another, just a few miles away, remains untouched. This contrast is part of the magic. It feels as if the lake has chosen where the snow should go. Meteorologists watch lake effect snow closely, especially near the Great Lakes of North America. Lake Erie, Lake Ontario, Lake Michigan. Their broad surfaces and unique wind patterns create perfect conditions for this kind of snowfall, sometimes producing several feet of snow in just a day or two. But the phenomenon is not limited to North America. Any large body of water paired with cold continental air can create lake effect snow. Japan, for instance, sees similar effects from cold Siberian air crossing the Sea of Japan. The snow itself is often fluffy and abundant. The air above the lake remains cold, but picks up so much moisture that clouds thicken quickly. These snowbands are often easy to see on radar. Lines of high reflectivity tracing over the landscape like brushstrokes. If you stand in one of these bands, it can feel surreal. The snowfall is intense, but strangely serene. Visibility drops, the world fades, and then, as suddenly as it began, you cross out of the band and the snow stops. Blue sky returns. It feels like stepping from one season into another. Lake effect snow is highly sensitive to wind direction. A slight shift can move the snowband miles away. And the size of the lake matters too. Larger lakes create stronger effects. Once the lakes freeze over, the process stops. The lid is closed. The breath ends. Residents of lake effect zones learn to live with this rhythm. Snowblowers at the ready. Quiet streets buried overnight. children waking up to surprise snow days. It's a pattern, but one full of surprises. From above, the lake glistens under cold skies. From below, the snow falls in silence, and in between, a band of clouds connects water to sky. This is Snowfall written in ripples, a winter whisper carried by wind and lake, a regional voice of winter, telling its story in snow. There's a particular kind of stillness found beneath snow-covered trees. The way branches hold their burden, the way silence gathers among the trunks. Snow doesn't simply fall on trees, it rests there, gently balanced, in an ever-changing art form sculpted by nature. Tonight, we wander into that quiet forest. As snowflakes descend, they meet the trees with gentleness. Pine boughs stretch outward like open hands, catching snow layer by layer. Each needle cradles a bit of white, and together they build a scene of winter softness. Deciduous branches, bare and reaching, become outlined in white, every twig highlighted like ink drawn across paper. But snow doesn't stick to every branch the same way. Its ability to accumulate and stay depends on several quiet factors. Moisture content plays a role. Dry snow with low water content is light and powdery. It settles delicately on branches without weighing them down. Wet snow, rich with moisture, clings heavily, bending limbs with its sleepy weight. Air temperature matters too. Just below freezing is ideal for sticky snow, the kind that clings to everything it touches. In colder conditions, snow is less adhesive and more prone to slipping off. The balance is delicate. And then there's the shape of the tree. Conifers like spruce and fir have downward angled branches that naturally shed snow. Pines, with their open structure, hold snow like cupped hands. Even the bark texture plays a role. Rough bark holds frost, and snow longer than smooth surfaces. From a distance, the forest appears transformed, coated in white, still and serene. But up close, each branch tells a quiet story of balance and resilience. You might see a single clump of snow resting on a tiny twig, seemingly defying gravity. Or notice how a long branch bows gently, snow stacked in lines across its surface. Trees respond to the weight in subtle ways. Branches bend but rarely break. Their flexibility helps them survive winter's pressures. Some even pulse, bouncing lightly to release snow after accumulation becomes too heavy. A breeze, a bird, or a settling flake might trigger the release. Snow on trees also shapes the soundscape. It dampens noise, softening the world. When snow-laden branches move, they do so slowly with a kind of reverence. The occasional creak or flutter of falling snow reminds us that even in stillness, change continues. In the morning light, snow on trees glows. Low sun catches the edges, turning branches into glowing veins of white and silver. The whole forest appears illuminated from within, and when the wind comes, it carries the snow off in swirling bursts, miniature flurries reborn from resting snow. This cycle of accumulation and release happens all winter long. Quiet, gentle, endlessly beautiful. Photographers, painters, and poets have long sought to capture this sight. Snow resting on trees evokes something deep, a reminder of balance, of endurance, of rest held lightly. So tonight, let us pause beneath a snowy bough. Let us look upward into the branches and notice the quiet artistry there, how the snow settles, how the tree adjusts, how nature holds even weight with grace. This is winter's sculpture, soft, temporary, perfect in its impermanence. There are moments when the world seems to disappear, not because of darkness, but because of softness. When snow lies thick upon the ground and fog wraps itself through the air, we enter one of nature's most ethereal combinations. Snow and fog together create a world without edges, without outlines, a world that feels more imagined than seen. Tonight, we step gently into that landscape. Fog forms when moisture condenses into tiny droplets suspended in the air. It's a cloud that lives at ground level, breathing around us, moving slowly, reshaping what we see. When snow is already on the ground, the cool surface can help fog linger. The cold beneath and the moisture above meet in balance, creating a hushed harmony. In this pairing, snow quiets the world from below, fog quiets it from above. The result is profound stillness. Trees fade into ghostly shapes. Houses become suggestions. Roads dissolve beyond the next curve. The snow underfoot reflects what little light remains, making the air seem to glow from below. Your footsteps vanish almost as soon as they're made. Sound is absorbed in all directions. You can hear your breath, your heartbeat, even the fall of a single flake. This is a world made of mist and memory, a place where time pauses. Meteorologically, this scene is rare. Fog usually requires moisture and stability. Snow prefers motion and chill. But under the right conditions, especially in valleys or near large bodies of water, they meet. Radiation fog, forming overnight under clear skies, may drift across snowy fields, or advection fog may move inland from lakes, blanketing snow-covered towns. Sometimes, freezing fog creates rime ice, adding even more texture to this dreamlike world. Trees glisten, fences grow feathers, every surface seems touched by frost. To walk through snow and fog together is to move inside a whisper. Your vision is limited, but your awareness expands. Details vanish, yet presence deepens. The world becomes immediate. Only what's in front of you, step by soft step. Animals appear and vanish like phantoms. A bird flits by, silent. A rabbit hops across the snow, its tracks the only sign it was ever there. Even the air smells different, cleaner, deeper, like distilled stillness. And when the sun rises or sets, the fog may glow with colour. Pink, gold, or pale blue light filters through the mist, making the snow shimmer like a dream. Photographs of these moments never quite capture the feeling. They show a world without detail. But being there is different. You feel held, surrounded, cradled by the atmosphere itself. Snow on the ground, fog in the air, a perfect quiet between them. So tonight, we let ourselves drift. No destination, just presence, just breath. This is a world softened in all directions, a world where even silence has texture. There are moments in the atmosphere when the sky doesn't quite know what to send down. One moment, it's rain. The next, snow. And in between, a graceful, nearly imperceptible transition. A change that happens not with drama, but with elegance. Tonight, we float through that change, from liquid to flake, from drizzle to drift. It begins high above, where the storm is born. All precipitation, whether snow, sleet, or rain, begins as ice crystals in the upper atmosphere. But as those crystals fall, they pass through different layers of temperature. If the air below is warm, the crystals melt and become rain. If the air remains cold from cloud to surface, the crystals remain snow. But when the layers are mixed, cold above, warmer in the middle, then cold again at the surface, interesting things begin to happen. In a gentle winter storm, you might feel the first drops of rain and wonder if it's too warm for snow. But then the air cools. Perhaps the sun dips behind clouds. perhaps a front shifts, and then the drops begin to change. At first, they're just cooler. Then you notice a flicker, a drop that doesn't splatter, but drifts. Another that seems to fall more slowly. The air thickens. Your coat gathers specks of white that don't quite melt. You are now in the transition zone. Some drops freeze mid-fall, others partially freeze, arriving as slushy pellets. Still others become snowflakes, soft, full, distinct. It's a dance of temperatures and timing. This changeover isn't just about degrees, it's about the depth of the freezing layer, the speed of falling droplets, and the moisture content of the air. Even small shifts in elevation can make a difference. A hilltop may receive snow while the valley below sees only rain. Meteorologists monitor these changes closely. Radar can detect shifts in precipitation type. Surface reports, temperature profiles, and soundings help refine forecasts. But even with data, the transition remains a living, breathing moment, and it's a beautiful one. Watching rain turn to snow feels like witnessing transformation. The air becomes quieter. The smell changes. Rain has a scent. Snow does not. The world begins to feel slower. You might notice how puddles begin to freeze at the edges, how rooftops gain a dusting that doesn't wash away, how the sound of falling drops becomes softer, more scattered, until it is replaced by silence. In this space between forms, we are reminded of the fluid nature of weather, of life. Change doesn't always come suddenly. Sometimes it begins in raindrops and ends in snowflakes. So let us pause in this in-between. Let the rain cool as it falls. Let the flakes begin to form. Let us watch, without rushing, as the sky slowly changes its mind. This is the poetry of precipitation, a story told not in thunder, but in temperature. We often hear about temperature when talking about snow, but another number, just as quiet and just as important, helps tell the story: the dew point. The dew point is the temperature at which air becomes saturated with moisture. Below this point, water vapor begins to condense. And when it's cold enough, that condensation forms not as rain, but as snow. Tonight, we gently explore this invisible boundary. Imagine the air around you holding moisture, vapor you can't see, but that's always there. The amount it can hold depends on temperature. Warmer air holds more, colder air holds less. When the air cools to its dew point, it can hold no more. Moisture condenses. In warmer months, this often leads to dew, fog, or rain. But in cold seasons, when temperatures fall below freezing, the dew point becomes the frost point. And that's where snow begins. Meteorologists watch the dew point closely. It tells them not just if it will snow, but how much and how soon. When the temperature and dew point are close together, clouds form. Precipitation becomes more likely. When they're far apart, the air is too dry. Snow may begin aloft, but evaporate before it reaches the ground. This is what causes virga, those streaks of snow or rain that vanish before touching the earth. It's a reminder that not all snow survives the journey. Understanding dew point also helps us read the snow's character. A higher dew point near freezing often means wetter snow, heavy, sticky, perfect for snowballs. A lower dew point means drier snow, powdery, light, easy to blow about. Even subtle changes in dew point can signal shifts in weather. A rising dew point may mean moisture is moving in. A falling one might mean drier, colder air is arriving. We don't see the dew point. We don't feel it directly, but we can sense its influence. On days when snow begins softly and steadily, when the sky seems heavy and the air damp with expectation, that's dew point at work. And on clear, bitter nights, when the stars are sharp and the snowpack glitters under moonlight, that's the dew point too, now low and dry. In forecasting, dew point helps define snow lines, altitudes where rain becomes snow. It shapes accumulation. It influences whether a snowstorm overproduces or fizzles out. But for us, tonight, it is simply a quiet marker, a signal whispered into the air, a number that helps us understand the soft arrival of snow. So the next time you step outside and see the first flakes fall, remember, it began with more than just cold air. It began with a balance, with invisible thresholds. Not all snow is still. Not all wind is wild. Sometimes they meet in the softest ways, a quiet dance between sky and air. In this chapter, we explore the gentle choreography of snow and wind, a ballet of drifting flakes, soft eddies, and the slow shaping of white across the land. When snow first begins to fall, it often drifts downward in stillness. But even a slight breeze can change its path. A wind just strong enough to lift a flake can carry it sideways, in circles, or across great distances. And unlike rain, which falls straight and fast, snow responds to every movement in the air. It rides the wind like a feather, floating, twisting, hesitating. Imagine standing in an open field as the snow begins. The wind is light. You watch flakes approach at an angle, not falling down, but drifting across. They catch in the folds of your coat, settle on your sleeves, spin near your boots. This movement is called drifting. Not the kind that forms deep banks, but the kind that feels like breathing. Snowflakes dancing with the air, rising and falling before they touch the ground. In forests, the wind filters through the trees. Snowflakes spiral gently among the trunks. They pause on branches, then lift again. In open plains, the wind has more room. It carries the snow farther, sometimes across roads, sometimes over rooftops. Small gusts create patterns on the snow's surface, ridges, ripples, and waves that mimic the flow of water. This is known as snow sculpting. The wind carves the snow into shapes, soft dunes, feathered edges, delicate crests. These aren't harsh forms. They are quiet, low, and subtle, like whispers made visible. Even long after snowfall has ended, the wind continues its work. It picks up loose flakes from the ground and moves them again, a process known as resuspension. A single snowstorm may settle several times before it truly rests. The kind of snow matters too. Dry, powdery snow is most likely to drift. It's light, airy, easily carried by the wind. Wet snow is heavier, more likely to stay where it lands. Temperature, moisture, and wind speed all affect this dance. And then, sometimes, the wind carries snow so lightly that it seems to hover. These are snow flurries on a breeze, not falling at all, but moving sideways in slow motion. Blowing snow when the wind becomes stronger can reduce visibility and create ground blizzards. But even then, there are moments of beauty when the low sun catches the swirling snow and turns it golden, or when moonlight turns a drifting breeze into a stream of silver. We often think of wind as something loud, but tonight we feel its quieter form, a soft hand guiding snow where it wishes, a sculptor, a dancer, a painter. So let us walk slowly through this drifting snowfall. Let us watch how flakes lift and land. Let us see the way wind gives snow new paths. This is not chaos. It is grace, a dance of white and air. High above the ground, in the heart of every winter storm, there is a boundary, a quiet line where snow becomes rain, or rain becomes snow. We call it the snow line, and tonight we rise gently toward it. This line is not fixed. It moves, bends, sways with the atmosphere. It is shaped by temperature, pressure, and the invisible patterns of wind. One moment, it hovers near the ground. The next, it lifts high into the clouds. It's a threshold the sky decides, moment by moment. As we ascend through a winter storm, we begin in the rain. The air is chilly, but not yet freezing. Droplets fall as water, tapping windows, soaking coats. But higher up, the air cools. We cross a subtle point, an altitude where the temperature dips below freezing. Here, the change begins. Raindrops start to freeze as they fall. First into wet snow, then into full flakes. Above this snow line, all precipitation falls as snow. Below it, that snow may melt into rain before reaching the surface. This transformation doesn't happen in a flash. It's a gradient, a layer of air in motion. Meteorologists call it the melting layer, and they study it closely. It helps forecast whether a storm will bring snow, rain, sleet, or freezing rain. Sometimes, the snow line hovers just above the ground. A few hundred feet in elevation can mean the difference between a green valley and a white hillside. In mountainous regions, it climbs with the terrain. In flat areas, it drifts up and down as warm or cold air pushes in. Even within a single town, the snow line can divide neighborhoods. One street sees flurries, another just rain. Radar and weather balloons help trace this line in the sky. But for those of us on the ground, it's something we feel. The moment the rain turns softer, colder, the moment flakes begin to mix. The quiet hush that follows when snow takes over. Pilots pass through it in flight, moving from clouds of rain into clouds of snow. Hikers may climb into it. Drivers may travel up roads that pass through it. And as we imagine rising with it tonight, we witness a kind of atmospheric decision. A place where water becomes lace, where rain lets go of its warmth, and the sky shifts into quiet. We may not see this line directly, but we see what it leaves behind, a storm's true gift, decided by a difference of just a few degrees. This is the snow line in the sky, a soft altitude where weather chooses its form, where storms become snow, where cold becomes beauty. There is a special quiet that descends on a city when snow begins to fall. The usual rhythm, the hum of traffic, the chatter of footsteps, the clatter of movement slows to a hush. The skyline remains, but something essential shifts. Tonight, we walk through a city held gently in winter's hand. Snow begins on rooftops. Thin layers form first, barely noticeable. Then, the eaves whiten, the lines blur, sidewalks soften, street lamps glow against the swirling flakes, lighting the snow from above and below. Cars move more slowly. People walk with quiet care. The pace of the city changes. What was loud becomes muted. Horns are softer. Tires hush across slush instead of humming over asphalt. Even voices seem to carry less. The soundscape reshapes itself. Cities, known for energy and motion, temporarily surrender to snowfall. The symmetry of buildings becomes abstract under layers of snow. Park benches wear white caps. Statues look older, wiser, with snow resting on their shoulders. There is a moment, often in the late evening, when the snow is fresh and the streets are nearly empty. A few lights glow in windows. A dog walker leaves faint tracks in the powder. The scent of cold and flake hangs in the air. It is then that the city feels most like a memory. This transformation isn't just visual, it's emotional. There's nostalgia in snowy cities, memories of childhood sledding, holiday lights reflected in slush puddles, snow angels made in unlikely places. Urban snowfall creates contrast. Neon signs glow warmer against the cold. Alleyways brighten with reflected light, and people become more visible. Coats dusted, scarves wrapped high, breath visible as mist. In a snow-covered city, humanity feels closer. Snow also brings challenges. Streets must be cleared, salt spread, transit delayed. But even amid the inconvenience, there is a collective pause, a shared awareness that the world has been temporarily redrawn. Balconies become soft platforms of white. Bicycles left outside wear snow like sculpture. Trees planted along sidewalks lean under the weight, becoming temporary guardians of the quiet. In parks, the snow covers everything: the grass, the benches, the paths. Children run, bundled and laughing. Snowballs fly. And then later, the city returns to stillness. Snow reveals patterns too. Footprints show where people walked, where they stopped, where they turned back. It tells the story of a day in soft impressions. The snow absorbs light and sound, but it reflects mood. It slows things down. And in that slowing, space opens for thought, for observation, for quiet. So tonight, we stroll through this softened city. We listen to the distant snowplow hum. We notice the curved outlines on once sharp buildings. We feel how the air presses lightly, as if urging stillness. A snow-covered city is not asleep. It's listening, and in its listening, it invites us to slow down and hear it too. High in the mountains, where the wind never truly rests, snow begins to shape itself in unexpected ways. Along ridgelines and cliff edges, it gathers and leans, building into forms that curl outward, weightless and sculpted. These are cornices, nature's delicate overhangs of snow. They form gradually, a flake at a time, carried by wind and placed with care. The process is slow, almost imperceptible. As the wind moves across a ridge, it lifts snow from the windward side and deposits it on the leeward edge. Over time, the snow builds outward, forming an arch that hangs in defiance of gravity. Cornices can grow large, sometimes many meters deep, but they remain fragile, hollow in places, unsupported beneath. Their beauty lies in that tension between lightness and danger, stillness and collapse. From a distance, cornices resemble ocean waves frozen mid-crest. Their edges are often feathered, wind-carved into fine curls and ridges. They catch morning light like glass, glowing gold, blue, or silver, depending on the time of day. Climbers approach them with respect. A misstep near a cornice can trigger a fall or an avalanche. They may look solid, but hide hollows beneath. To the untrained eye, the edge of a cornice can blend with the rest of the snowfield, disguising where the land ends and the overhang begins. Meteorologists study cornices as part of snowpack analysis. Their formation indicates prevailing wind directions, storm strength, and accumulation patterns. A growing cornice tells of strong winds, sustained snowfall, and cold temperatures. A broken one may reveal structural weaknesses in the snowpack. But beyond their scientific and practical roles, cornices offer a lesson in form. They are shaped by invisible forces. They don't resist the wind, they yield to it, allowing it to sculpt. In the silence of the alpine air, you can hear the wind pass over them. It hums, not sharply, but with a smooth, ribbon-like sound. The ridge whispers through the cornices, and the snow, in turn, becomes voice. Some cornices last all season. Others collapse during a thaw or under their own weight. When they fall, they release a cloud of snow and echo across the slope. But even then, they are part of the mountain's rhythm, a cycle of build, break, begin again. Skiers, hikers and forecasters mark their locations. Pilots note them from the air. Photographers wait for perfect light. But to sit beneath one, quietly, is to witness something truly temporary, a sculpture made of air and time. So tonight, let us imagine ourselves atop a quiet ridge. The air is cold, still. Before us, a cornice hangs over the valley, glowing in the moonlight. Not dangerous now, just beautiful. A curve of snow, placed by wind, held by cold. And in that moment, we feel what the mountain feels. Not fear, not urgency, only balance. No two snowflakes are alike. It's a phrase we've all heard, a poetic truth passed down like folklore, embroidered onto scarves and whispered by winter itself. But is it fact, or just a beautiful myth? Tonight, we take a gentle journey into that question. At the heart of the statement lies a truth rooted in science. Snowflakes, those delicate ice crystals that fall from cold clouds, are formed under such complex conditions that the chance of two being exactly identical is incredibly small. Each flake's design is sculpted by temperature, humidity, pressure, and time. The combination of these variables changes constantly, even within the same cloud. A snowflake begins its life as a tiny nucleus, dust, pollen, or another small particle, around which water vapor condenses and freezes. From there, it grows outward, branching in 6 directions. This 6-fold symmetry comes from the shape of water molecules and the way they bond in cold temperatures. But the speed of growth, the angles of each arm, the thickness, the intricacies, these vary. So, in essence, every snowflake has a fingerprint. But what does alike really mean? If we look closely, under a microscope, we'll see that some flakes resemble each other very closely. Simple plate-like crystals may be nearly indistinguishable to the human eye. But the exact arrangement of molecules, the fine structure, the tiny imperfections, those will differ. Wilson Bentley, known as the Snowflake Man, photographed thousands of snowflakes in the early 1900s. In all his work, he never found two exactly the same. Modern imaging and computer modeling agree. While categories of flakes exist, the precise shape is always unique. Still, there's a caveat. In laboratory conditions, scientists can grow nearly identical snowflakes. By controlling temperature and humidity, they can replicate shapes. But these aren't natural. They're grown in still air, under carefully matched settings. Out in the wild sky, that level of stability doesn't last. Nature prefers variety. So while it's theoretically possible for two snowflakes to be alike, the odds are unimaginably small. The atmosphere would have to maintain identical conditions across both flakes for their entire journey, each flake taking the same path, at the same speed, through the same layers of air. It's like asking if two leaves from two trees are ever exactly the same. Similar, sure. Identical, unlikely. And yet, the beauty isn't just in their uniqueness, it's in their creation, in the way the atmosphere whispers instructions and the flake responds, in the idea that something so fleeting, a snowflake that lasts only moments on your glove, carries a design never seen before and never again. Some flakes are simple, solid hexagons, small and flat. Others are lacy and branching, stretching into complex dendrites. Some grow like needles, some as columns, some capped with little plates. The variety is endless, a gallery of frozen art drifting from the clouds. So, the next time you hear "no two alike," you can smile, knowing that while the phrase may not be technically provable, it holds a poetic truth, a celebration of nature's subtlety, of tiny differences made visible. And that truth is enough. Each flake is a fleeting masterpiece. Each one a whisper of weather's imagination. No two alike, just close enough to wonder. It's a phrase passed from neighbor to neighbor on icy days. It's too cold to snow. But is that really true? Tonight, we float into this chilly question and gently uncover the science behind the snow. First, the basics. Snow can fall at extremely cold temperatures. In fact, it has been recorded in places as cold as 40 degrees Celsius. The air doesn't stop snow from forming just because it's cold. In the upper atmosphere, where snowflakes begin their journey, temperatures are often far below freezing. Snow is born in the cold. So why do people say it can be too cold to snow? It's not that cold prevents snow. It's that very cold air usually lacks the moisture needed to create it. Cold air holds less water vapor than warm air. At 20 degrees, the air can only carry a fraction of the moisture it could at 0 degrees C. Without moisture, clouds can't form. Without clouds, there's no snow. So, on bitterly cold days, the sky may be crystal clear. The snow from a previous storm still blankets the ground. But above, dry, silent air, nothing falls. This dryness gives rise to the too cold myth. The air isn't incapable, it's just too empty. But there are exceptions. In polar regions and very high altitudes, snow can still fall in deep cold if moisture is introduced, sometimes from a passing front, sometimes from ocean air mixing in. The snow in these cases is often light and powdery, tiny flakes that fall slowly and drift like feathers. Meteorologists watch more than just the thermometer when forecasting snow. They look at the dew point, atmospheric moisture, pressure systems. A frigid forecast doesn't rule out snow, but it may mean less of it. Interestingly, some of the most intense snowfalls occur when temperatures are near freezing. Around 1 exacts to 3 degrees Celsius, the air can hold more moisture, and flakes are larger, stickier, and more plentiful. This is the perfect range for heavy snowfalls, the kind that coats everything quickly and sticks like a wool blanket. Colder than that, the flakes are smaller, the snow lighter, and the totals often lower. But the snow is drier, easier to shovel, and sparkles more in moonlight. There's also the psychological side. On very cold days, we tend to notice the stillness, the sharpness of the air, the way sound travels. Snowfall feels improbable in that silence, but silence isn't the same as impossibility. So, is it ever truly too cold to snow? Not exactly, but it can be too dry, too still, too clear. And in that clarity, we feel the absence of snow, even as the cold deepens around us. So tonight, wrapped in warmth, let us remember, the cold does not cancel the snow. It only waits for the right breath of moisture. And when that breath comes, no matter how cold, the snow will fall, soft, silent, certain. There are moments when snow looks like it's made of stars, tiny twinkling bursts of light catching your eye. You step outside on a cold, sunny morning, and the snow seems to shimmer with life. It's not magic, it's light, playing with ice. Tonight, we slow down and watch that play unfold. Snow is made of countless crystals, each with flat faces, angles and sharp edges. These surfaces reflect sunlight in many directions, depending on how the flakes are positioned and how the light enters the snowpack. When the sun rises low on the horizon, its rays skim across the top layer of snow, catching those angles just right. That's when we see the sparkle. This glitter effect, often called diamond dust, is especially visible when the air is dry and the sky is clear. Each ice facet acts like a tiny mirror, sending a single beam of sunlight outward. When hundreds, thousands, even millions of these reflections hit your eyes, the result is a dazzling shimmer. But not all snow sparkles the same. Newly fallen snow, especially when temperatures are below freezing, creates the best effect. That's because fresh flakes haven't been compressed or melted. Their edges are still sharp. Their crystals remain separate. Over time, sunlight and warmth round off those sharp angles, fusing flakes into a duller surface. So, if you've ever wondered why yesterday's snow seemed brighter than today's, it's in the structure. The fresher the flake, the brighter the gleam. This phenomenon also changes based on time of day. Early morning and late afternoon, when the sun is lowest, are ideal times for sparkles. The light enters at an angle, grazing the snow instead of blasting straight down. That shallow light path increases the chance of hitting those reflective surfaces just right. Sometimes, even moonlight can create a subtle shimmer. It's much fainter, much softer, but on nights with a full moon and cold air, the snow may appear to glow. Not glittering, perhaps, but glowing, a faint sheen that looks like frost caught in a dream. Another factor is snow type. Dry, powdery snow sparkles best. Wet or compacted snow doesn't. Its surfaces are smoother, more fused, less reflective. You might still see a dull glint, but not the sharp sparkle of dry crystal faces. And of course, wind plays a role. A light breeze might shift the snow's surface, just enough to change the way light bounces. A still morning might preserve those perfect angles for just a little while longer. It's fleeting, ephemeral, but that's the beauty of it. The sparkle of snow reminds us how light can transform a landscape. It turns the ordinary into the extraordinary, not through drama, but through quiet brilliance, through geometry, through timing, through the angle of a crystal just waiting for the sun. So, next time you see that shimmer, pause. You're watching nature bend light through frozen breath. Not magic, but something close. Snow may appear still, quiet, even sleepy. But beneath its soft exterior lies one of the most important systems on Earth. The long, slow, vital journey of water. Tonight, we'll follow that journey. When snow falls, it doesn't disappear. It rests. It waits. It holds moisture, sometimes for days, sometimes for months. This stored water becomes essential during the changing seasons, especially spring, when rising temperatures melt the snow and release that moisture into rivers, lakes, and aquifers. In many parts of the world, snow is the primary reservoir for fresh water. Mountain ranges act as natural storage tanks, snow accumulating through winter, then melting gradually into streams. This meltwater feeds agriculture, replenishes ecosystems, and provides drinking water to millions. So while snow might seem like a pause in the cycle, it's more like a quiet holding pattern, a frozen moment in a much larger story. When snow lands, it covers the ground in a white blanket, insulating the earth beneath. This helps protect soil and plant life during harsh winter temperatures. Beneath the snow, roots continue to breathe. Tiny creatures burrow, and the soil stays at a steadier temperature than the freezing air above. As temperatures rise and the snowpack begins to melt, that water doesn't just vanish. It follows paths carved by time, trickling into creeks, swelling into rivers, and sometimes sinking into the ground to recharge underground aquifers. The pace of this melt is crucial. Too fast, and it can cause flooding. Too slow, and it may not reach distant ecosystems in time. That's why scientists carefully measure snowpack depth and density in regions that depend on it. The snow's water content is just as important as its depth. A light, fluffy snowfall holds far less water than a dense, heavy one. The snowpack becomes a predictor, a quiet forecast of spring's abundance or scarcity. Snow also plays a role in reflecting sunlight. Fresh snow has high albedo. It bounces most of the sun's rays back into the atmosphere. This helps regulate Earth's temperature, keeping the planet cooler than it would be with bare ground. As the snow melts, darker surfaces absorb more heat, accelerating seasonal change. Even evaporated snow contributes. Sublimation, the direct transition of snow to vapor without melting, sends moisture back into the atmosphere. It's a subtle exhale, but part of the cycle all the same. So, while snow may seem passive, it is, in truth, a vital connector in the planet's hydrological story. It stores, it releases, it regulates. It holds the pause between cloud and river, between storm and stream, a frozen breath that eventually returns. Not an end, but a promise. Let's approach this chapter with stillness and softness. Avalanches are often portrayed with intensity, but here we explore their quiet beginnings, the gentle shifts that build up over time. Avalanches don't begin with drama. They begin with layers. When snow falls, it doesn't always blend smoothly with what lies beneath. Each snowfall creates its own unique layer, with different densities, temperatures, and moisture content. Over time, these layers stack like pages in a book, each one fragile in its own way. Sometimes, a weaker layer forms beneath a stronger one. Maybe it was a powdery snowfall, or a layer shaped by hoarfrost crystals, delicate and loose. When heavier, wetter snow falls on top, it presses down. If the bond between these layers is weak, the balance begins to shift. But still, nothing happens. Not yet. The snow holds until something tips the balance. It could be another small snowfall, a rise in temperature that subtly changes the snow's structure, or even the softest vibration, a footstep, a voice, a breeze through the trees. And then one layer slips, the surface breaks, and the snow begins to move. It's not always fast, it's not always loud. Some avalanches start slowly, just a soft slumping of snow, a movement like a heavy sigh rolling down a hill. Others are more sudden, but in this gentle telling, we focus not on the aftermath, but the process, the quiet signals the mountain gives, the way snow talks to itself in tension and release. Meteorologists and avalanche forecasters study these signals carefully. They measure snowpack layers, observe recent storms, track wind direction, and listen to the snow. Snow can speak if you know how to read its patterns. Even sound is part of this story. In the stillness before an avalanche, the snow often creaks and groans, tiny sounds that reveal its inner shift, like the pages of a book rustling before they fall open. Avalanches also differ in type. There are slab avalanches, where a large, cohesive layer breaks away from the slope, and loose snow avalanches, more like a cascade of powder, starting from a single point and spreading. Each has its own quiet fingerprint, shaped by snow type, slope angle, wind, and sun. And though avalanches can be dangerous, they are also a natural part of the snow's life cycle. They clear slopes, redistribute snow, and help shape mountain landscapes. So tonight, we hold no fear, only understanding. Avalanches are not always loud warnings. They are gentle reminders that nature balances on subtleties, that a soft surface may hide layers in tension. That change, when it comes, can be quiet, almost invisible. So let's listen to the layers, to the weight, to the moment before movement, a breath held in snow, and then released. Let's approach this chapter with stillness and softness. Avalanches are often portrayed with intensity, but here we explore their quiet beginnings, the gentle shifts that build up over time. Avalanches don't begin with drama, they begin with layers. When snow falls, it doesn't always blend smoothly with what lies beneath. Each snowfall creates its own unique layer with different densities, temperatures, and moisture content. Over time, these layers stack like pages in a book, each one fragile in its own way. Sometimes, a weaker layer forms beneath a stronger one. Maybe it was a powdery snowfall, or a layer shaped by hoarfrost crystals, delicate and loose. When heavier, wetter snow falls on top, it presses down. If the bond between these layers is weak, the balance begins to shift. But still, nothing happens, not yet. The snow holds until something tips the balance. It could be another small snowfall, a rise in temperature that subtly changes the snow's structure, or even the softest vibration, a footstep, a voice, a breeze through the trees. And then one layer slips, the surface breaks, and the snow begins to move. It's not always fast, it's not always loud. Some avalanches start slowly, just a soft slumping of snow, a movement like a heavy sigh rolling down a hill. Others are more sudden, but in this gentle telling, we focus not on the aftermath, but the process, the quiet signals the mountain gives, the way snow talks to itself in tension and release. Meteorologists and avalanche forecasters study these signals carefully. They measure snowpack layers, observe recent storms, track wind direction, and listen to the snow. Snow can speak if you know how to read its patterns. Even sound is part of this story. In the stillness before an avalanche, the snow often creaks and groans, tiny sounds that reveal its inner shift, like the pages of a book rustling before they fall open. Avalanches also differ in type. There are slab avalanches, where a large cohesive layer breaks away from the slope, and loose snow avalanches, more like a cascade of powder, starting from a single point and spreading. Each has its own quiet fingerprint, shaped by snow type, slope angle, wind, and sun. And though avalanches can be dangerous, they are also a natural part of the snow's life cycle. They clear slopes, redistribute snow, and help shape mountain landscapes. So tonight, we hold no fear, only understanding. Avalanches are not always loud warnings. They are gentle reminders that nature balances on subtleties, that a soft surface may hide layers in tension. That change, when it comes, can be quiet, almost invisible. So let's listen to the layers, to the weight, to the moment before movement, a breath held in snow, and then released. Snow falls light, like feathers, like breath. But wait a while, and it begins to press. In this chapter, we explore the quiet heaviness of snow, not with urgency, but with calm curiosity. Snow, after all, is not always as light as it seems. Let's begin with what we see: a dusting on a tree branch, a soft pile on a rooftop. At first glance, it's gentle, but snow is made of water, and water has weight. The type of snow makes a difference. Dry, powdery snow, formed in colder temperatures, is lighter. It contains more air, fewer water molecules. But wet snow, falling closer to freezing, is dense. A single cubic foot of powder might weigh 5 pounds. That same volume of wet snow could weigh 20. As snow accumulates layer by layer, its weight compounds. What begins as a light coating becomes a deep blanket. Roofs begin to creak under pressure. Trees bend under the burden. utility lines dip. Nature adapts. Pine trees, for example, have flexible branches. They curve downward with snow's weight, then slowly rise again as it melts. Some trees even shed snow deliberately, vibrating in the wind to release it. But others can break, their limbs unable to bear the load. Buildings, too, are designed with snow in mind, especially in snowy regions. Engineers calculate snow load, the maximum expected weight of snowfall, and build with sloped roofs or reinforced beams to handle it. Snow doesn't fall evenly, either. Wind drifts it into corners and ridgelines, piling it deep in some places, while leaving others bare. A roof may look clear from the ground, but hide a heavy drift tucked into a sheltered side. The weight of snow also plays a role in avalanches, as we explored earlier. Heavier layers atop weaker ones add pressure, increasing the chance of movement. But snow's weight isn't only physical, it's emotional, symbolic, a quiet presence that changes how the world feels. When snow falls, it dampens sound, slows footsteps, covers familiar places in unfamiliar softness. That weight changes our pace. We move slower, speak softer, stay closer. And inside that stillness, there's a kind of rest. The world seems heavier, but in a way that makes you want to curl up, not run away. Even animals adjust. Deer paw gently at the snow to uncover food. Squirrels pack down their paths. Snow creates challenges, but also shelter. Beneath its weight, the ground is warmer, protected from the wind. In spring, when snow begins to melt, its weight transforms into flow, into water that nourishes the soil, fills rivers, and feeds the land. What was once a burden becomes a gift. So yes, snow is light, and snow is heavy. It rests softly on your shoulders, and it shapes the world beneath. A paradox in white, a quiet presence, with quiet strength. There is something quietly magical about snowfall at night. Not during a blizzard or a storm, but during those still, hushed hours when the world has gone quiet and the flakes begin to fall. In this chapter, we place ourselves beneath a lone street lamp, watching snow drift downward through the light. It begins with a glow, a soft pool of amber spilling from the lamp, stretching in a gentle cone through the darkness. Then, from above, the snow enters, one flake at a time. Each flake catches the light differently. Some spiral slowly, like tiny dancers. Others flutter sideways, caught in a faint breeze. It feels as if time itself has slowed to match their pace. The world beyond the streetlight fades into shadow, becoming distant. But here, in the small circle of gold, everything feels close, familiar, safe. The snow doesn't rush, it takes its time. If you listen closely, you might hear the tiniest sound, the faintest whisper as the snow touches ground or brushes your coat. But mostly, it's the silence that speaks. Snowfall at night is quieter than snow in the day. There's less traffic, fewer voices. Even the air seems to hold its breath. The flakes fall through stillness and become part of it. Sometimes, the light glints off a flake just right, and it sparkles for a moment, a tiny burst of reflected gold. Other times, they remain shadows of themselves, soft and grey, barely visible, but always moving. You might watch them and wonder, how far did they travel? What shape did they begin with? Did they fall from a low cloud or drift down from high above? Each snowflake's journey ends here, in this quiet pool of lamplight. Children see magic in this sight. Adults feel nostalgia. And for all of us, there's a kind of peace, a reminder that even in cold and darkness, beauty persists. The snow begins to collect on the pavement, on the curb, on the empty bench nearby. It softens the world, covers imperfections, rounds off the edges. Some street lamps flicker slightly, and when they do, the snow seems to pulse. A living snowfall, bathed in heartbeat light. There's science here too. The way light scatters off snowflakes has to do with their crystal structure. Tiny facets that reflect and refract, bending the light in many directions. That's why they shimmer and glow as they fall. The stillness of night air helps too. Without wind, the snow drops gently, vertically, letting us trace its motion. It's like watching gravity paint in slow motion. And though we're surrounded by cold, the scene feels warm. Maybe it's the color of the lamp. Maybe it's the quiet. Maybe it's just the softness. Whatever the reason, snowfall under streetlights feels like a lullaby in motion. So tonight, we don't rush. We don't explain everything. We simply sit and watch. Let it fall. Let it glow. Let it bring a hush to your thoughts, as it brings peace to the ground below. When you step outside on a winter morning, you may notice something curious. Your shadow on the snow isn't dark, it's blue. This chapter is a quiet meditation on light, and how it touches snow. Let's begin with the snow itself. Snow is made of ice crystals, tiny prisms that scatter light. When sunlight strikes snow, it reflects in all directions. Some of that light enters the snowpack, bounces inside, and then exits back out. This internal scattering gives snow its brightness and its softness. But what happens when something interrupts that light? A tree, a person, a fence post. They cast a shadow, yes, but the snow around that shadow is so bright, the absence of direct sunlight reveals something else. Color. In winter, the sun sits low in the sky. Its light travels through more of the atmosphere, scattering blue wavelengths along the way. When a shadow falls on snow, the bluer tones, reflected from the open sky, become more noticeable. That's why snow shadows are not black, but a soft, silvery blue, and they're never harsh. Snow softens even the deepest contrast. Edges blur, lines fade. The landscape becomes a pastel painting, gently brushed with light. The time of day also changes everything. Early morning shadows are long and cool. As the sun rises, the shadows shorten, but their color deepens. Late afternoon brings golden light, and the blues of the shadows become richer, more saturated, yet still gentle. This interplay of light and shadow creates a winter palette like no other. Pale lavender along a drift, blush gold near the horizon, blue-grey under the trees. Even on cloudy days, snow finds a way to reflect what little light there is, giving the world a silvery, ethereal glow. Artists have long been fascinated by these colours. The Impressionists, in particular, tried to capture the way winter light dances on snow. But even they admitted, the real thing is softer, more subtle, impossible to hold. And for meteorologists, snow's reflectivity matters too. Snow has a high albedo, a measure of how much light it reflects. This helps cool the Earth's surface by bouncing sunlight back into the atmosphere. In essence, snowlight doesn't just brighten the world, it helps balance it. There's a mood that comes with winter light. It asks us to pause, to see not just the brightness of the snow, but the gentle hue of everything it touches. So next time you walk through a snow-covered field, notice your shadow. Not dark, not sharp, just softly blue, fading into white. A quiet dance of colour, a stillness painted in light, a landscape, dreaming beneath the sun. Snow does not disappear in haste. it departs with patience. In this quiet chapter, we observe the gentle farewell of winter's touch as snow begins to melt. It often begins with light, sunlight returning after long grey days, touching the surface of the snow with soft warmth. The top layer, exposed to this warmth, begins to shift first. Ice crystals loosen their grip. Flakes that were once rigid begin to soften, their intricate shapes slowly dissolving into droplets. You might notice this change in the way snow sounds beneath your feet. No longer the crisp crunch of frozen powder, but something softer, wetter. A hush with a hint of slush. The melt doesn't happen evenly. Some areas thaw from the top down, as sun-warmed surfaces gently absorb heat. Others begin from below, where ground warmth slowly rises, loosening the snow's hold from underneath. In these places, pockets of a space form. You might see snow sagging, air beneath it, like a pillow letting out a breath. Close your eyes and listen. Drip, drip, drip. Each sound is a signal. Transformation is underway. Droplets gather at the edge of a roof. They cling, shimmering, then fall. One by one, they land on stone, on leaves, in puddles. Tiny, consistent, persistent. And it's not just water that's moving. With each melt, the snow releases what it once held. Dust, pollen, even small air bubbles trapped since the storm began. These join the flow, continuing their journey in liquid form. Sometimes, the snow refreezes overnight. Melted patches turn slick. Icy surfaces form where droplets had begun to run. And then the sun returns, and the thaw resumes. This cycle can repeat for days. In the right light, you can see the sparkle of thawing snow. It glints not from dryness, but from moisture. Wet crystals shine differently, like glass rather than silk. It's the snow's way of saying, I'm still here, but I'm changing. In this chapter, we don't rush the process. We stay with it. Watch the icicles shrink. Listen to the soft gurgle of water in a nearby drain. Feel the cool mist rising from melting fields. Beneath trees, snow melts first. Branches intercept sunlight, warming the air beneath them. Patches of grass appear like soft secrets. Life begins to stir. Melting snow doesn't shout. It hums, it whispers. And with each drop that falls, winter leans back, and spring leans in. The transition is not dramatic. It is gradual, layered, thoughtful. The snow remembers its origins, formed high in the clouds, carried down by cold, now rising again as warmth welcomes it back to the cycle. So when you witness snow melting, think of it not as an end, but a continuation, a quiet return to movement, a soft sigh of change, and a promise that nothing, not even winter, stays the same. Snowmelt is one of the Earth's most gentle gifts. When snow blankets mountaintops and hillsides, it rests there, storing moisture through the quiet months. It waits in stillness. Then, as the sun lingers longer in the sky and temperatures rise, the snow begins to release that stored water, but not all at once, slowly, softly. This chapter traces the path of melted snow, from high elevations to winding rivers. It's a journey shaped by slope, gravity, temperature, and time. It begins with trickles. A patch of melting snow on a hillside starts to drip. The droplets gather in small grooves, which widen into rivulets. These rivulets find other rivulets, and together they form miniature streams. These tiny flows slide between pebbles and over moss. They follow the path of least resistance. Some disappear into the ground, nourishing roots and awakening seeds. Others keep moving, growing wider, deeper. Eventually, they meet a stream. The stream is fuller now, fed by many melts. It runs cold and clear, humming softly as it winds through forests and fields. You might hear it before you see it, whispering its presence through the trees. These waters are ancient travelers. Their course is guided by the land itself, etched over time by countless snowmelt seasons. Snowmelt-fed rivers are lifelines. They supply drinking water to towns far below. They replenish reservoirs. They feed crops and wetlands, allowing ecosystems to thrive. The release of snowmelt is nature's form of pacing. If the melt happens too fast, floods can occur. But if temperatures rise gently, the melt remains steady. Rivers swell without overflowing. The balance holds. In some regions, snowmelt accounts for more than half of the annual river flow. Without it, summers would be drier, plants would struggle, lakes would shrink. Snow, so soft and quiet in winter, becomes a powerful source of life in spring. There's a kind of music to this transformation, the steady rhythm of dripping, the crescendo of streams, the deepening voice of rivers. You might stand by a riverbank and see the shimmer of snowmelt, cool currents sliding past rocks, reflecting sunlight in ripples. You might dip your hand into the water and feel the memory of mountains, the chill of high-altitude snowfall flowing past your fingers. And it's not just water that moves. Snowmelt carries nutrients downstream, minerals that enrich soil, feed algae, support fish. It's a thread in the larger fabric of the water cycle. What once fell from clouds now returns to the sea. So tonight, we follow this journey with care, from frozen ridgeline to flowing stream, from silent melt to steady river, a story of patience, a path shaped by time, a gift of snow, becoming life. Sometimes, peace can be held in the palm of your hand. A snow globe, small, round, delicate, holds a tiny world inside, a frozen moment, a quiet winter scene waiting to be stirred. One gentle shake, and the flakes begin to swirl. Not with chaos, but with choreography. They rise, fall, twist, and glide, all within the stillness of glass. In this chapter, we explore the snow globe, not only as an object of memory or imagination, but as a metaphor for how the atmosphere, too, has its sealed moments of suspended calm. Let's begin with the globe itself. Inside, a miniature world rests, perhaps a cabin, a forest, a quiet town. The scene never changes. Only the snow moves, set in motion by touch, then slowing until it drifts down again in peace. This motion mimics real snowfall, but in reverse. In the sky, snow begins in the clouds, falling downward. In a globe, it is shaken upward first, then drifts slowly back down. It's a closed system, a weather story inside glass. Now, let's float gently upward, into the real atmosphere. There are moments in the sky when everything feels like a snow globe. Wind calms, temperatures settle, snow drifts slowly with no rush to the ground. Meteorologists call it light snow, but to the rest of us, it's a kind of dream. Like the flakes in a globe, each one falls independently, yet they create a scene together. They soften the edges of trees, rooftops, and roads. They hush the air. When you shake a snow globe and watch the flakes descend, time seems to slow. The same can be true when watching snowfall from your window. Minutes stretch, breathing deepens, thoughts settle. There's a quiet magic in the stillness. And even within storms, there can be lulls, pauses, moments when everything is suspended, a meteorological breath being held, like the middle of a snow globe's fall when everything floats, not up, not down, just there. Snow globes remind us to slow down, to look closely, to sit with the quiet. They hold space for memory and imagination. Maybe you've seen one with a scene from your childhood town, or a place you long to visit. Maybe you've given one as a gift, hoping to share a small piece of calm. Snow globes aren't just souvenirs. They're symbols, a pause in time, a moment of softness, a reminder that stillness has beauty. Just like real snowfall, brief, gentle, and worth watching all the way to the end. When snow is on the way, there's a kind of anticipation in the air. But tonight, we won't rush. We'll gently observe how meteorologists look ahead, quietly reading the atmosphere for signs that snow may come. Forecasting snowfall begins with questions. Is the air cold enough? Is there enough moisture? Will the winds guide clouds over land or sea? The answers lie in soft clues, temperature profiles, dew points, wind patterns, and cloud cover. These clues are gathered by satellite, radar, surface observations, and weather balloons. Each piece adds to a broader picture. Let's start with radar. Weather radar sends pulses into the atmosphere. When these pulses encounter precipitation, they bounce back, revealing where snow is falling and how intensely. On the screen, snow often appears as soft blue or violet, moving slowly across the map like watercolor on paper. Then, satellites. From far above, satellites watch cloud patterns. They see where clouds are forming, how high they reach, and how cold they are. Bright, cold cloud tops may hint at snow-producing systems. Next, the temperature map. Forecasters look not just at surface temperature, but at layers of the atmosphere. Snow forms high above, but to reach the ground, it must pass through air that stays below freezing. If there's a warm layer in between, snow may melt into rain, or refreeze as sleet. Forecasts often show a snow probability. This number is a blend of data and possibility. It might say 70% chance of snow, but behind that number are dozens of models, each suggesting a slightly different outcome. No forecast is perfect, but each is a soft suggestion, a whisper from the sky. Meteorologists don't just predict, they prepare. They inform road crews, airports, schools. But here, in our quiet chapter, we focus on the beauty of the tools, the care taken to watch clouds form, the curiosity behind predicting a single flake's fall. Snowfall forecasting is part science, part art, a feel for how storms breathe, a sensitivity to the signals, a patience with the unknown. Sometimes snow arrives gently, other times forecasts change, but when it does come, there's something comforting in knowing the sky was watched, that someone noticed, that the snow was expected. And as you look at a forecast, symbols of clouds, flakes, or chilly temperatures, let them be a soft invitation, a reason to prepare cocoa, to find a blanket, to listen to the hush that may soon arrive. Because snowfall, predicted or not, is always worth noticing, and the quiet science behind it, just as beautiful. Not all snow falls the same way. Some snow arrives like a whisper. Others rush in with breathless urgency. But even then, we speak softly. In this gentle chapter, we explore two different types of snowfall, flurries and squalls, and the moods they bring to the sky. Let's begin with snow flurries. Flurries are light, fleeting bursts of snow. They fall with little accumulation, almost like sky dust. You might step outside and see a few flakes drifting, swirling, barely touching the ground. Sometimes they vanish as quickly as they appear. They don't often show up on radar. They're shy, subtle, a passing thought from the clouds. Flurries are the gentle reminders that the sky is thinking about snow. Not quite a storm, not quite still, a middle place. They can appear in bright sunlight or under a cloudy veil. You might notice them against the backdrop of a street lamp, or see them sparkle in the breeze before disappearing again. Now let's meet their livelier cousin, the snow squall. A snow squall is brief, intense, and very specific. It can sweep through in minutes, lowering visibility, tossing flakes sideways with the wind. But even in a squall, we look not for chaos, but for pattern, for meaning. Squalls happen when cold air masses collide with warmer ones, creating instability. The atmosphere briefly loses balance and expresses it with a burst of snow. Winds pick up, the sky darkens, the air thickens with movement. Then, just as suddenly, stillness returns. To the casual observer, the difference is simple. Flurries are light and quiet. Squalls are heavier and faster, but both are short-lived. Both are beautiful in their own way. Meteorologists track squalls carefully. Though they are short, they can surprise. A squall line on radar looks like a narrow band, moving quickly, but precisely. It may cross one road and skip the next. A flurry, on the other hand, may not even register. There's poetry in both. Flurries invite us to pause, to notice, to stand still and let the moment drift around us. Squalls remind us that even the sky has moods. That change can be sudden and still be part of nature's rhythm. When you next see snow falling, ask yourself, is this a flurry or a squall? Is it a soft conversation or a sudden announcement? And either way, let it be a moment of observation, a reminder that weather, like thought, moves in waves, some gentle, some bold, but always worth watching. Snow falls everywhere, but not equally. Some places receive just a delicate dusting once every few years. Others live beneath a constant sky of snow. In this quiet chapter, we travel gently, exploring the snowiest corners of the world. Not to rank or compare, but to observe, to admire the variety. Let's begin in Japan. The town of Aomori, on the northern tip of Honshu, is often blanketed with some of the heaviest annual snowfall on Earth. Here, snow can pile up in walls taller than a house, but the atmosphere remains soft. People move slowly, sweeping roofs, clearing paths, always coexisting with the snow. Next, to Canada. The city of St. John's in Newfoundland is no stranger to snowstorms. Yet, despite the volume, the snowfall here is often described as calming, quieting the streets, slowing the pace. It's not just how much snow falls, but how it's felt. In the United States, places like Syracuse, New York, and Mount Baker in Washington record high snowfall totals. Lake effect snow plays a role here, where cold air gathers moisture from lakes and then releases it inland. It can snow for hours, gently, endlessly. Now to the Alps, the Himalayas, and the Andes, where high altitudes make snowfall part of daily life. In the mountains, snow isn't just beauty, it's water, stored for spring, a quiet reservoir. Antarctica too gets snow, but very little. It's technically a desert. The air is too cold, too dry. What little falls stays, sometimes for thousands of years. A record not of depth, but of time. Even deserts can see snow. In 2016, the Sahara was dusted in white, a quiet miracle. The snow melted quickly, but for a moment, sand and snow met in silence. Some places have records for the deepest snowpack, others for the longest snowfall, yet others for earliest or latest flakes. But we're not here to measure, we're here to marvel. Each region's snowfall has a personality, soft in some places, fierce in others, always shaped by air, moisture, land, and time. Snow is not about numbers, it's about experience, a shared phenomenon across languages, continents, and cultures. And as we drift back from our quiet travels, we carry with us a map, not of places, but of moments, a rooftop in Japan buried deep, a street in Canada hushed in white, a mountain in the Alps softened in fog, a flurry in the desert. All of them snowfall, all of them part of the same soft story. Can snow have a scent? For those who felt it approaching, the answer is a quiet yes. There's a moment just before the flakes begin to fall when the air changes. It becomes still, cooler, almost metallic, as if the sky is holding its breath, and in that breathless pause, a subtle scent rises. Tonight, we explore the soft mystery of snow's scent. The scientific name for what we sense before a snowfall doesn't point to a single smell. Instead, it's a combination of atmospheric changes, cold air, lower humidity, and the absence of stronger scents that usually fill the air. As moisture condenses and the temperature drops, volatile compounds in the environment are subdued. Trees stop releasing oils. Soil goes quiet. Humidity holds scent particles closer to the ground. And the result? A crisp, clean aroma that many describe as fresh. It's not that snow has a smell, but that the world smells different when snow is near. Some people describe it as similar to ozone, that faint, sharp scent that sometimes comes before a thunderstorm. Others say it smells like iron, or minerals, or nothing at all. But it's there, waiting in the stillness. The scent of snow is also shaped by memory. For many, it smells like childhood, like mittens and wool, like early school closures and first steps into a white blanketed yard. Our brains tie scent to moments, and snow's scent is often a gateway to nostalgia. Cold temperatures also play a role in how we perceive smell. When the air cools, our olfactory receptors behave differently. Certain smells become more noticeable, others fade. The scent of pine may grow sharper, the scent of soil fainter. The world becomes a softer version of itself. As snow begins to fall, sound dampens, and scent follows suit. The snowfall acts like a muffler, not just for sound, but for the environment as a whole. The world feels tucked in. Even our senses settle down. Imagine walking down a quiet road before a snowstorm. The air tingles on your face. Each breath feels pure. There's no floral note, no spice, no smoke, just the simplicity of clean air, cooled to the edge of frost. That is the scent of snow. It is the smell of stillness. And when the snow finally begins to fall, soft, slow, and steady, it brings with it a confirmation of what the air was already telling us, that something peaceful is arriving. It may seem strange, but snow, so cold and silent, is also warm, not to the touch, but in the way it protects. Tonight, we'll gently explore the insulating nature of snow and how it shelters the earth, even in the deepest part of winter. Snow is made of countless crystals, each one a tiny architecture of air and ice. When snow accumulates on the ground, it traps air between those crystals, and air, as it turns out, is a very poor conductor of heat. That means the warmth from the ground has a hard time escaping, and the cold from above has trouble reaching below. The result? A quiet layer of protection. Under a deep snowpack, soil temperatures often remain stable, even as the air above may dip far below freezing. This thermal barrier keeps roots from freezing, seeds from dying, and hibernating creatures safe in their winter sleep. Burrowing animals like mice and voles live in what's called the subnivean zone, the space just beneath the snow. It's a miniature world, warm, dark, safe. Tunnels wind between the ground and snow above, hidden from predators, insulated from the bitter cold. Even larger animals benefit. Bears dig their dens into snowy hillsides. Foxes curl up in shallow snowbeds. The snow doesn't feel warm, but it holds warmth in. Plants too rely on snow. Delicate buds, dormant grasses, and evergreen roots all rest beneath its cover. Snow provides moisture and temperature control, keeping the growing world safe until spring. And for humans, snow can serve as insulation too. In extreme cold, snow shelters, like igloos or snow caves, can retain warmth from body heat. Carefully constructed, they offer a refuge from the elements, using the very coldness around them to protect from deeper cold. So while snow might seem like winter's breath made visible, it is also winter's blanket. It softens sound. It cradles roots. It wraps the world in a quiet kind of care. The next time you walk past a snow-covered field or forest, imagine the life sleeping just beneath the surface, safe, still, untouched by the wind above. Snow is not just the end of warmth, it's the keeper of it, a silent guardian, a quiet shelter, and a reminder that even in the coldest parts of the year, nature finds ways to care for itself. Some weather systems gather with potential. The atmosphere leans in, moisture collects, and cold air settles into place. And yet, nothing happens. Tonight, we turn our attention not to storms that roared, but to the ones that whispered and then passed us by. The snowstorms that never quite became. It begins, as so many snowfalls do, with a pattern in the upper air. Jet streams shift, surface lows begin to form, clouds build, wide, gentle, uncertain. Meteorologists take notice. Models predict possibility. The conditions are close. But then, something changes. Perhaps the cold air retreats ever so slightly. Maybe the low-pressure center drifts too far from the coast. Maybe dry air mixes in. And like a dream that fades before waking, the storm unravels before it can take shape. These are called near-miss snow events. Atmospheric setups that almost bring snowfall, but don't. And their science is a quiet lesson in sensitivity. Snow requires balance. Not just cold air, but moisture. Not just moisture, but uplift. All must align delicately, like a clock whose hands only meet for a moment. If one part falters, the storm never forms. From the ground, we might feel the chill. We might see clouds stretch overhead. We may even sense the scent of snow in the air, but no flakes arrive. To the untrained eye, it feels like a promise broken, but to those who study weather, it's simply the atmosphere choosing stillness. Some storms appear on radar, drifting far offshore or dissolving over mountain ranges. Some begin to drop snow, only to stop an hour later. These are ghost storms, echoes of what could have been, and there's something peaceful in that. In a world so often focused on action, it's calming to observe the storms that chose not to come, the sky that prepared itself, and then changed its mind. Even the atmosphere has pauses. Not every pattern needs to culminate. Not every cold front must deliver. Tonight, we rest in that in-between space, the quiet of a storm that never was, a lesson in patience, softness, and letting go. Sometimes silence is the forecast, and sometimes it's enough. There comes a time, soft, unannounced, when the snow falls for the final time that year. It doesn't always feel like an ending. There's no ceremony, just flakes drifting slowly through warming air, settling briefly on the greening grass below. This is the last snow of the season, a quiet farewell between sky and earth. In this final chapter, we drift into that tender moment. It begins with surprise. Perhaps the trees are budding, perhaps spring. Birds are already singing. And yet, one more snowfall arrives. Light, fleeting, melting as it lands. There's a softness to these late flakes. They fall through air already turning warm, through wind that no longer stings. They know their visit is brief. Meteorologically, the last snow happens when the balance finally tips, when daytime highs grow too warm for accumulation, when the atmosphere loses its cold grip, when moisture still lingers but can no longer cling. Sometimes the last snow comes at night, vanishing by morning. Other times it blankets the world one more time before melting into puddles by noon. It is snow with no intention of staying. And yet, it still matters. For some, the final snow brings nostalgia, a reminder of childhood sled rides or quiet evenings by a winter window. For others, it brings relief, one last pause before the bloom of spring. It's also a meteorological threshold, a moment when the season truly turns, when winter bows and spring takes the stage. The final snow may go unnoticed by many, but for those who pause, there is beauty in its transience. A flake lands on a budding branch. A roof warms and snow slides off, disappearing into soft sound. The ground, no longer frozen, accepts the melt eagerly. And the sky, it clears, as if it too understands that the time has come. We often mark the first snow with excitement, but the last snow deserves attention too. It is a gesture, a closing sigh. In this gentle ending, we are reminded that weather, like life, moves in quiet cycles, that even farewells can be soft, and so we let the last snow fall, not with sorrow, but with calm, a final gift from winter, a soft whisper of goodbye. And as our snowy exploration comes to a close, may the hush of falling flakes, the calm of white-covered fields, and the soft silence that follows snowfall stay with you tonight. We've wandered together through frozen clouds and gentle skies, tracing snowflakes as they formed, floated, and fell. We've watched crystals grow, winds sculpt, and moonlight shimmer across icy landscapes. We've felt the softness of snow's embrace and the stillness it leaves behind. I hope this quiet journey brought you a sense of calm, a pause, a place to rest. Even in the coldest corners of the atmosphere, we've found warmth in understanding and softness in the science of snow. If these peaceful weather stories bring you comfort, you're always welcome to subscribe or return again, only if it feels restful to do so. There's no rush, just gentle presence. Now, let your breath slow, let the flurries fade behind your thoughts, and let your dreams drift like snowflakes, weightless and slow. You are safe. The sky is quiet now. Good night, dear friend. Peaceful dreams, and calm skies to you.